Physical and chemical properties of substances. Each substance has a set of properties that is characteristic of a substance and gives it a unique identity. For example, color, taste, odor, all these are physical properties. Color, taste, odor. Um, Other than that, density, melting point, boiling points, these are also the physical properties. Now, what are physical properties? These are inherent in the substance and can be determined without altering the composition of the substance. On the other hand, chemical properties describe the ability of a substance to interact with other substances to form different substances. For example, combustion is a chemical property. What is combustion? Combustion is burning. When you're burning anything in air, that's combustion. For example, if you see, like, for example, methane gas, when you burn that in air, it forms carbon dioxide and water. So that means combustion is a chemical property because why? Because it describes the ability of a substance to interact with the other substances and form the new substances. Now, what is a physical change? A physical change is the change in the physical properties or is a change in the state of matter for a substance without altering the composition. For example, melting and boiling point or melting and boiling, not the points, melting and boiling are the physical changes. Why? So you have water, if it's in the form of ice, it melts and form water which is in the liquid. This is a physical change. Why? Because only the state is changing but not changing the composition. We still have water, H2O. Similarly, when you boil water, you're making vapors, but you still have water. You have not formed a new compound, only you have changed the state. On the other hand, when we talk about chemical change converts one substance to the another and the identity of the original compound is lost. Now, this, for example, going back to combustion, we started with methane. Methane burned in air, which is combustion, or we can say on combustion, methane forms carbon dioxide and water. We do not have our original compounds, we have completely new compounds. Let's talk about the next concept, which is energy. What is energy? Energy is the capacity or the ability to do work. There are two main units of energy we're going to use in this chapter, calorie and joule. And you need to know the relation between these two units, and 1 calorie equals to 4.184 joule. Now, given the energy in one unit, you should be able to convert it to the other one. For example, 20 joules of energy is how much in calories? How are you going to do that? You write down 20 joules, draw a line, put 1. Here in the denominator put joules and here put calories, and then write down the relationship. 1 calorie equals to 4.184 joule. Cancel joule with joule. So 20 divided by 4.814 will be the answer. Now there are different types of energies. The main two types of energies that you need to know are potential energy and kinetic energy. Kinetic energy is the energy due to motion, and potential energy is the stored energy. That's the energy that results from position or is stored within a substance. Now we said calorie here is the unit of energy. Now how to define calorie? Uh, for example, if we say 1 calorie, 1 calorie is the amount of heat required to raise the temperature of 1 gram of water by 1 degree Celsius. So let's say you take 1 gram of water, and if it is at the temperature of 25 degrees Celsius and you want to change it to 26 degrees Celsius, how much heat you need to provide? You need to provide 1 calorie of heat, and this is the way we define calorie. Uh, in chemistry, energy is most frequently expressed as heat, and energy can be used to cause chemical changes. Now, we also learned that the SI unit for heat energy is the joule. Now, here, the next thing that you need to learn is what is the specific heat, which is denoted by SH. Now, every substance has a characteristic heat capacity, means it can absorb a specific amount of heat. So what is the specific heat of a substance? Is the quantity of heat required to raise the temperature of 1 gram of substance by 1 degree Celsius. Now this specific heat value is a constant value for each and every compound. For example, specific heat of water, if you look here, specific heat of water is 4.184 joules per gram degree Celsius. What does that it means? What does this mean? This means that if you want to change the temperature of 1 gram of water by 1 degree Celsius, then 4.184 joule of heat needs to be supplied, or 4.184 joule of heat is required to raise the temperature of 1 gram of water by 1 degree Celsius. That's the specific heat of water. So let's look at this problem here. How many joules of energy or heat are required to raise the temperature of 150 grams of water from 15 degrees Celsius to 45 degrees Celsius? Now the formula is heat equals to, this is the formula, heat equals to mass of the substance times specific heat of the substance times delta T. And what is delta T? That's change in temperature. And what is change in temperature? Final temperature minus initial temperature. Mass is 150. Specific heat of water is a constant number, which is 4.184 for water. Delta T, final minus initial. Final temperature is 45, initial is 15, so the change is 30. So heat will be, you multiply these three numbers, so this is the answer. So all you have to do is to put the value of mass, specific heat, final temperature and initial temperature in this formula to calculate heat. Next problem here, for this one, this problem, an iron pin, the specific heat of iron is given at 110 degrees Celsius is dropped into 50 ml of water at 15 degrees Celsius. After a couple of minutes, the temperature of water reaches 17.4 degrees Celsius. What was the mass of the iron pin? So here what's happening, there's an iron pin and you are dropping that, which is at the temperature of 110 degrees Celsius, you're dropping this iron pin into the water. And the water is at the temperature of 15 degrees Celsius. When you drop this iron pin into the water, then this iron pin loses the heat and that heat goes into the water and the temperature of water changes from 15 to 17.4 degrees Celsius. So the question is, what is the mass of the iron pin? So the first thing what you're going to do, first you're going to calculate Q of iron, which is mass times specific heat times change in temperature, which is final minus initial. What is the mass of the iron pin? We don't know. We don't know the heat, but we know the specific heat of iron pin, which is 0.473. Final temperature, when you put the iron pin into the water, and if the water is showing 17.4 degree, that's the final temperature. And initial temperature of iron pin was 110 degrees Celsius. Similarly, you calculate Q of water. Again, mass of water, 50 ml of water means 50 grams because density of water is 1. Specific heat of water is 4.184. Final temperature is 17.4 and initial temperature of water was 15 degrees Celsius. Now, the thing is, what you need to understand here, that the heat lost by iron is gained by the water. So what we are going to do is we're going to say Q iron equals to negative Q water. That heat lost by iron is gained by water. So anything, whenever some loss is there, that's you denoted by the negative sign. So that means what you're going to do, this whole thing equals to minus of this thing. And if you look here in this relationship, the only variable you have is m. So m here, now 17.4 minus 110 degrees Celsius, you're going to do that first. You're going to write it down. So what are you going to write down? M times 0.473 times 17.4. Now 17.4 minus 110 degrees, 17.4 minus 110 is negative 92.6 equals to, then there is a negative sign, 50 times 4.184 times 17.4 minus 15 is 2.4. And to calculate m, all you have to do is divide both sides with this number, 0.473 negative 92.6. So this cancels out, negative sign cancels out with negative. And when you're going to do all this, 50 times 4.184 times 2.4 divided by these two numbers, you are going to get 11.46 grams. And we have to round this into 2. You have to report the answer in 2 sig figs. So then it's going to be 12 grams. 12 grams is the answer. Why do we have to report it in 2 sig figs? Because look at the numbers given in the question. 110. How many sig figs are in 110? 2. 50.0 has 3. 15.0 has 3. 17.4 has 3. So the lowest is 2. So that's why the answer has to be reported in 2 sig figs.
Made with Doodlecast Pro.